So, we're going to continue with the afternoon session. The next speaker, Gilles Retsin, originally from Belgium. Gilles is an architect and designer living in London. He studied architecture in Belgium, Chile, and the UK, where he graduated from the AA. His design work in critical discourse has been internationally recognized through awards, lectures, and exhibitions at major cultural institutions, such as the Museum of Art and Design in New York, the Royal Academy in London, and the Centre Pompidou in Paris. He recently edited an issue of Architectural Design on the Discrete and has co-edited Robotic Building, Architecture in the Age of Automation, with Titel Verlag. Gilles Retsin is Program Director of the Master Arch Architectural Design at UCL, the Bartlett School of Architecture. He is also co-founder of UCL AUAR Labs, which does high-profile research into new designs and fabrication technologies, and its spin-out company, AUAR Limited, a startup working towards an automated platform for affordable housing. So, with you, Gilles Retsin.
Thank you, Tiago and Filippa, for inviting me to your beautiful city, to Porto. My talk today is called Beauty in Large Quantities. And I think that will become clear towards the end what I mean with that, which I think ultimately is maybe the purpose of an automated architecture. And the talk is split in two parts, so we'll start with some provocations. I always like to do that. They will be kind of a bit blunt, they will be maybe theoretical, maybe bad jokes, we'll see. And then the second part are some propositions, because just doing provocations by themselves, I think, is not necessarily productive. So let's start with the provocations. This one you probably all know, like this figures in a lot of slides, also in this conference. The world needs to build 2 billion new homes over the next 80 years. For me, the most interesting question here is who will build those 2 billion new homes? And mainly the question maybe that is interesting for us, like will there be any architects involved in that process? And we're not so well set up to deliver those 2 billion homes. These are two of the most, I think, important graphs to understand everything that is wrong with our profession and with the built environment today. Is a reason why when you graduate from architecture school you will have a low-paid job. Is a reason why you will be fighting if you start your own office to even struggle to build a single house. And it's the reason why that if you have a construction company in Europe, that your profit margin will be 1%. And what is that? That's that construction, the productivity of construction has flatlined since 1947. So that means that if you would have invested in any other business except construction or architecture, you would have done pretty well. Like you see, everything is going slightly better. Now, why is that? That's probably the graph on the left. The graph on the left shows the level of digitization or automation in all industries. And you see, of course, per definition, the industry that is most automated is, of course, the computer industry, right? The IT industry. And the least automated one is agriculture and hunting, and then you have construction. But actually, that's not entirely true. In the Western world, agriculture is actually highly automated. So the only profession that is less automated than construction and architecture is hunting, which I hope we keep like this, because hunting should be a craft, right? It should be we don't want to start hunting with like robots and drones, I hope. But I don't believe that construction and architecture actually should be a craft. I think we should actually consider automating that. That's 1947, right? So we could say that since Le Corbusier started building l'unité d'habitation in Marseille in 1947, whatever we have done in architecture and construction has not fundamentally changed anything. Despite BIM, despite AutoCAD, anything. We're not building any better now than we did then. That also means that this model, probably one of the most stupid and at the same time one of the most intelligent models, is still unbeatable. This is the best model. We cannot do better than this, right? And that's the beauty of architecture. I think architecture always, if you try to be too smart with architecture, it always hits back at you. You know, you need to be a little bit kind of, it's quite a blunt profession. It doesn't tolerate too much intelligence. But it could maybe have been us. It could maybe have been us architects building these 2 billion homes, if we had not stopped thinking about it. In 1972, modernism officially ended, according to Charles Jenks, with the detonation of one of the largest housing projects in the world, Pruitt-Igoe. And since then, we have stopped that project of thinking on a large scale about architecture. We have stopped being utopian. We have stopped kind of believing in a future and also in a kind of societal role for architecture. And since then, architecture is this. I'm from Belgium. The entire architecture world is now Belgium. I call that Belgification. So Belgification is, on the one hand, it's a gift because Belgium architecture is extremely beautiful. It's very well crafted, it's very creative, but it's also extremely, extremely small scale. These people will not build 2 billion homes for you. There is no idea about building 2 billion homes. And it's not only Belgium. I mean, Spain has been Belgified since the financial crisis in 2008. There were some big ideas in Spain, but now they're gone. Now they're just doing really beautiful, really good work. France has been radically Belgified, which is nice because normally France does things to us, so now we do things to France, so that's nice. But generally, actually, you know, are there any intellectual ideas today in architecture that are able to tackle even that question, right, of building homes on a massive scale? I mean, architecture, I believe, truly has never been as good as it is today. It's just incredible how much incredibly good work there is. I can't buy all of these crocuses. It's just unendless. And there's so many good practices, but they're all what you would call boutique practices. 10 people, 15 people, beautiful houses, beautiful libraries, maybe here and there. And that model of architecture treats every building as a prototype. Every day for an architect is a new day. This is architecture today. It reminds me of this really bad Adam Sandler movie, which you absolutely should not watch. So he's dating this girl, and she forgets every day what she, you know, her entire life. So every day they need to start dating again from scratch, right? It's nice in Portuguese, like every day is the first day. And that's architecture. Every project we do, we start again from scratch. And my question is really, and that's maybe the main provocation, if a building is good, why don't we repeat it? What's the problem with repeating a good building? If you design a good building once, why don't we do it 1,000 times if it's that good? Like London, where I live. I mean, London is a repetition of the same building. Every building is the same building. It's a pretty good building, not particularly interesting. There's no concept behind them, but they're pretty good. Everyone wants to live in them. And why would we have to design every building again? Like if you have a good one, why not repeat it, right? So it could have been us, architects. It could have been us also when we started to work 20, 30 years ago with digital design methods. We were really good at that. But the question that we were asking what to do with these digital methods had nothing to do with a societal question. It had nothing to do maybe with how it could change like the profession of an architect. It was actually boutique. It was a boutique question. It was how to, instead of repeat buildings, how to make sure that every single building is even more different than it was before. Right? So that is kind of architecture that you associate with digital and with, like that's what I learned in school many years ago. And again, it's not that I don't like this work. I think it's very optimistic. I think it's interesting. It was daring. It was also completely defined by a context before the financial crisis, by a neoliberal context that these projects were, you know, there's no housing there, right? This was museums for wealthy people. Oil sheikhs, etc., etc. But it could really have been us, I think, if we look back at what's happening both east and west of the Berlin Wall in the 70s, in the 50s, with people like Miguel Fisac who are questioning fundamentally how we should build today. This guy tried to make his own factory. He designed the elements that he wanted to build with. He was not going to build with a brick or a piece of timber. He wanted to reset construction from scratch and reinvent it. Or this unknown Soviet engineer, I find this a beautiful picture, who's posing next to his panel that he has created, right? It could have been us. It could have been Walter Gropius and Konrad Waxman. After they left the Bauhaus, they started the General Paneling Company in 1948 with the idea to build 10,000 homes a year in the United States. They built a factory. It produced 20 homes. And it was a beautiful idea. It was the idea to repeat one single idea for a building 10,000 times. But never exactly, because ultimately they are architects, so it would never be exactly the same building. Every building was a combination of parts, and it would always result in something slightly different. They were even teaching this in Harvard. The students could only work with this kit of parts of Waxman and Gropius, and then you could design buildings with it. So who will it be? It will be tech. It will come somewhere from this soup, which is a kind of a crazy ecology that we call the construction tech markets, which are companies that are engaged in all kinds of little bits and pieces of the value chain of how buildings come into being, from development to construction. And there's a small group somewhere there in the middle, Blockable, Juno, Woho, which are companies that are ironically doing exactly where architecture stopped in 1972. So 1972, the idea was that mass housing was a social democratic socialist project. And it got stopped because we entered another era of neoliberal capitalism, Thatcher, Reagan, etc. So that project stopped. And now, ironically enough, the pinnacle of capitalism, venture capital, is looking back at where we stopped as architects and is taking this into a new context. So they are working with, in a way, this guy here, and they're trying to automate that guy. And they're trying to repeat this guy thousands and thousands and thousands of times. So this is the house of the future. It's not very exciting, right? But on the one hand, it is also very exciting. It looks kind of unexpected, but this is really the house of the future. That's an automated house. But I mean, maybe the good news is it's not happening, because the company who was behind this was an American company called Katerra. They got $2 billion in funding that was thrown at making this house automated, and it failed. They went bankrupt, which is again kind of the beauty of architecture. Now, even with 2 billion, you can't do it. Like, it's still kind of, it's a long journey still. And part of the reasons, I think, also is because they left really off where modernism started. They shouldn't look that much back. They should actually look maybe a bit more recent at what we could actually do with new technologies, with robotics, with automation, with AI, and not try to kind of replicate the Soviet Union housing factory with venture capital, which is what they were doing. We need to be optimistic. Optimism is a moral duty. There are some really interesting companies actually started by architects in this tech world. So there's Woho Systems, which is founded by Anton Garcia Bril and Deborah Messa from Ensemble Studio. They're doing fantastic work. They started a startup, they got funding, and they're trying to push beautiful, beautiful prefabricated systems, very intelligent ones, into the world. There's Intelligent City, which is based in Vancouver, but is mainly populated with young architects who had been studying in Europe, in Stuttgart, and brought knowledge of robotics and automation to this company. And they have a beautiful vision on what architecture could do. So that's some of the provocations. And now some propositions. So I will slowly guide you a little bit to how we are approaching this. And I'll do that a little bit with the work of my research lab at UCL, which is called Automated Architecture Labs. My own architecture office, because I also have a boutique little practice that does tiny little projects. That's called Gilles Retsin Architecture. And then ultimately my tech company that is called Automated Architecture AUAR. So first of all, the proposition I think is clear, that we could think about digital technologies in a historic parallel with mechanization. So mechanization, and I'm not going to do a whole academic lecture here about mechanization, but mechanization was the paradigm that was underlying, of course, modernism. And that's a story that goes from policies of labor to ideas about housing to ideas about how we should live. And it's actually very funny that, you know, the Amazon warehouse that you see there on the right, that is actually the epitome of automation today. That is digital fabrication. That is digital making, the Amazon warehouse. And it actually, at least you see there's an ambiguous relationship, right, between these images on a kind of very superficial level. They don't look that different. Of course, they are terribly, terribly different. The people who work in the Amazon warehouse have no, you know, they're gig workers. They don't have, they would never be able to be like a Ford employee who was paid a decent salary and could buy their own car. That's social democracy. This is kind of something that we don't know maybe anymore what it is, some form of neoliberalism. But we could consider in a way automation as a very important project for architecture, probably the most important project for architecture. So that's why you should buy this book. You can buy it on Amazon, on this evil warehouse there. You can buy this on Amazon, Robotic Building, which also has contributions of some of Fabio and Matthias and many others here, which tries to kind of lay out that paradigm, right? Automation. And also automation, it's important, right? Because it's not only a technology, but it also has immediately socio-political consequences. There's immediately questions around labor, around work, around who is benefiting from this, who owns these robots, who owns these factories. There's many funny questions on the book there, like what is a robot? Is a washing machine a robot? Like these are all questions around automation. And we took a specific position towards automation, and it's not the only one. You can take many positions, but my position that I took is that I truly believe that the solution to automate architecture lies in one of the most simple and banal ideas, and that's the idea that architecture is made of parts. And that's like a blunt and an interesting statement, but we could actually do a project for digital technologies and automation, not about funky surfaces or Zaha Hadid buildings or kind of where everything looks very different, but really about very simple building blocks, very simple parts, a disciplinary kind of history of architecture. And the unique thing is that these are parts that precede buildings. So today, if you design a building, you first design the form of the building, and then you figure out the parts for that building. This is completely the inverse. We have to design parts that exist before the building exists. Parts that don't know about the building. And architects have always tried to do this, and they've also always failed, to be honest. But of course, you have Frank Lloyd Wright, who designed the textile block, Alfred Bemis, who designed a kind of a universal cuboid, as he called it, and then Gropius and Waxman with the General Paneling Company. Or also, again, Frank Lloyd Wright, when he was playing with Froebel blocks, maybe the little timber blocks that you played with as a child, right? Or even, you know, the primordial essence of architecture was parts that preceded the building. You would find these parts in nature, you would stack them, and then you have a building. So we approach that through the question of building blocks, which are kind of elements that have no specific function. They're not columns, they're not beams, they're not doors, they're not windows. They're generic elements that have to be good at anything. And we design those elements specifically in such a way that they are good for robots. Bricks are made for humans, building blocks are made for robots. In the same way, you know, Louis Kahn, like the brick fits in the human hand, etc., etc. And these elements are very generic and very stupid and very blunt, right? And they just need to be sure that they can always do the job. It's a little bit like a Volvo, you know, the philosophy behind Volvo, the cars, is that they never need to be really good. They just need to be a 7 out of 10, not an 8, not a 5. It's the same with these blocks. At everything that they do, they just need to be okay, right? And it's really the idea to forget everything that we learned about architecture, everything, that entire messed up world of how we build buildings today out of thousands and thousands of parts that you need to cut into tiny little pieces to fit the sketch that you have done on a napkin, and then these parts travel from all over the world and are sold by annoying salespeople who send you brochures. That entire world disappears, right? We reset architecture from scratch and think, first of all, with which material, which parts are we going to build architecture today? That means that this domino, that very dangerous and stupid and super smart and intelligent model that keeps following us, maybe disappears. And it doesn't disappear in a kind of a superficial way. It disappears at its core. Like the building, the diagram on the right is no longer a domino. Nothing in that model is shared with the model on the left. It's an entirely different idea about space, about design, about production, and possibly, and we'll see that later in the lecture, also about the model of the architectural practice. And this is a little bit the manifesto behind that thinking. So automation, my position in automation is that automation would mean the digital distribution of parts. And it's all about the word distribution that allows us to talk politics. Who is it distributed to? It allows us to talk economics. What are the platforms and the models for its distribution? It allows us to really be really true architects and talk about the consequences, the aesthetics, the experiences of this distribution of parts. And then you can also be philosophical about it. So I'll show you a little bit some work that we're doing in our lab in UCL, which is kind of work that is not immediately applicable in today's world. And then I'll show you some work of my boutique office that shows a little bit how it is applicable in the real world. So that could be kind of a fully automated architecture, right? This is a kind of an abstract robot, it's not even shown, that is just stacking this kind of generic building blocks and piling them up, growing it almost kind of in a little building. And I think you will see the little robot, that's actually the robot that assembles it, that is walking over it. Or it could be this. This is kind of a vision on a fully automated architecture where the orange block is a robot and it grabs the white block that is not a robot, that's just a brick. And it kind of flips around and assembles structures. And then some of these robots could collaborate with each other and kind of build walls. That's one of these robots walking around in the corridors in the Bartlett in London. And yeah, doing funny things. Oops. Then we tried that out on a larger scale to kind of simulate how these robots would work with industrial robots, showing kind of their assembly. We use AI to train these robots. This is a process called reinforcement learning, where we basically bully these robots thousands and thousands of times until they learn how to do the job. And then we kind of speculate on these scenarios of assembly, right, of how you could distribute a program. You would dump a few containers with these robots, and then thousands of these little robots would basically kind of grow your building. So it's a strange version almost. I would say that this is kind of almost actually kind of an organic architecture, although it only consists of straight parts, right? But you could almost say that this is a kind of a truly organic architecture. It's also, you could say it's kind of modernist because it's repeated parts and modules, but it's actually totally not, right? It's purely kind of thought through a digital method. So that's a little bit the work we do in the university, but then with my own practice, I try to build little homes and win little competitions as a cute boutique architect in Belgium. And there we try to kind of explore that model and also truly understand like what it means for architecture beyond maybe the technology. Like what are the consequences for space, for experience of these spaces, right? Like what does it mean if a building has no, like is made only of these generic parts? This is the first time I tried this. It was a very naive attempt. So I made this kind of arrow-shaped brick and then aggregated that, and I ended up with this kind of model which I really liked because it looked extremely strange. It's an assembly, it's modular, it's all repeating units, but at the same time it also looks strangely organic and strangely natural. And I thought that was very interesting. And I was cheating a bit. Only the white parts are repeating, the red parts are customized, but they still have kind of repeating connections. And I really liked the outcome of this, although I had absolutely no idea how to build this thing. Like this, I could never build this. But I really liked everything that was in this model. I thought it looked primitive, it looked assembled, it looked strangely natural, but yet still kind of maybe also reminiscent. You would immediately know that this is kind of made for humans, but then, you know, because of the kind of the flat articulation. But I thought this was really kind of a truly interesting language. So then I had a chance to build that. I won a competition for a small pavilion in Tallinn, and I decided to build a domino, a maison domino, but in this method to kind of show it's like an abstract unit that wants to be repeated. And it's just built of essentially of this kind of blocks, which again are kind of arrow-shaped. That's just plywood, so it's just timber, super cheap. One sheet of plywood is one block. And then they're connected with very long steel threaded rods that keep this together under tension. So you can always undo the screws and your building comes back to its parts. And you can use these parts again to build other buildings. So with the same parts, you could build a whole variety of buildings. You see here this kind of Lego blocks for adults, right? Really large models, and then it looks very different from each side of the pavilion. So it was kind of a playground to explore these different qualities, sometimes more rectilinear, sometimes more jagged. Pretty crazy architectural moves that you could do with this, while at the same time it was super, super, you know, efficient and both materially efficient and labor efficient. And of course, this is then the idea for the kind of the speculation on what this pavilion would look like as a kind of a housing block, where every instance of this housing block could be different while repeating everything at the same time, right? This is just kind of one element that keeps repeating. So an apartment doesn't have to be like a 1, 2, 3 bedroom apartment or a studio, but every single instance could be different. And then I did this other speculative model, which I think is one of the best examples of to understand what an architecture that only consists of parts that precede the building, so parts that do not understand the larger building, how that would look like, a pure kind of aggregation, right? There's no columns, there's no beams, there's no floor slabs, there's just a straight part and an L-shaped part that are repeating and aggregating into this form. And it looks massive, but actually it's not massive. This is not massive timber. These are, again, very thin sheets of timber. So this was a house, kind of a multi-family house with 3 apartments. And then I think, again, from an architectural perspective, this is a very strange space. It's actually also like a cave, right? It's a very primitive space, where the same material defines everything around you. And then I had a chance to build a section of this in the Royal Academy in London for an installation. So we built like a small part to kind of really be able to sit there and be there and kind of explore how it works, and also to prove that you could actually kind of, at least in a museum context, that we could kind of build this, right? These are kind of parts of the ceiling. And then I recently, with the boutique practice, then convinced a client, an innocent client, to try this out for his house. And it's a typical Belgian project. It's a kind of house extension, and it's very simple. It's just, it's a very boring architectural idea, actually. It's just a surface and a column, right? 3 columns that carry this kind of table with a roof light. Then we built it, so we built it ourselves together with the client. So we pre-assembled these massive blocks. You see the tension rods to connect these blocks together. And we just kind of, added these pieces together and assembled that into the building. A very strange building site where you're just playing around with these large blocks and slowly kind of growing the building on the site. We did that in 4 days. We had it built, so that was very nice, just before Christmas. And then I think this is quite interesting to consider this, because this is not anything expensive. This was super, super cheap, like dirt cheap, right? And it's still, I think, a kind of incredibly interesting and exciting and strange space, which has this kind of primordial and primitive qualities, the things that we know, the column and the roof, what you would think. But then it becomes really interesting to the fact that actually nothing in this building has anything to do with how you would build today, right? And kind of purely the consequences of these parts result in this kind of strange hybrid qualities of that building. And then these are some other speculations for a villa in a forest which play with the same idea. So that could be modular architecture, right? And again, I like this thing that in a way it's a very kind of blunt and primitive idea. It's exactly the same as what these guys were doing, right? There's no difference. The only difference is that to do that on the left today is too expensive and we can't do it, and it's not materially efficient. But this we can do today, right? But it's exactly the same. So really old and really new is maybe the same, right? Maybe we end up where we started, and I quite like that. And then the question is also, how scalable is this, right? Like, I mean, how would you do that on a larger scale? So and one of the competitions that I did, where we ended up in the last round for a concert hall in Nuremberg in Germany. So we had to extend the existing concert hall. So to trick the German jury, we just designed in the first round a simple square block. So the Germans were like, perfect block, yeah. So they chose it, but then in the second round, it turned out that nothing in this block, it was Pandora's box. Like, it had nothing to do with any kind of standards or ways of how you would build a concert hall. The entire concert hall is laid out flat here. It's completely made of CLT sheets that form a limited number of repeating modules. So that's everything you need to build a concert hall. And then that's the kind of the computational idea. We just had, it's called I won't go in detail, it's a voxel space with lots of these little V-shapes. They aggregate, and then they get kind of formed into this extremely repetitive modules, right? And then it results in this building, which I think, again, is kind of like a timber cave. It's a monolith. It's highly repetitive, yet also differentiated, like nothing. It's not a kind of a simple repetition. And again, I think this building is extremely radical. It's not a box. It's a building that has no columns and no floor slabs. Like, there are literally no floor slabs in this building. There are no columns. The parts that you see in the wall are exactly the same parts as in the ceiling and even on top. And of course, I was willing to compromise on this, but our engineers from Bollinger Grohmann had calculated that actually, because of fire regulations, the sections of timber at the bottom have to be the same thickness as the ones at the top. Because obviously, if you would build this without fire regulations, you could use thinner timber on the top. But actually, fire regulations override everything. So they were just like, yeah, we just use the same section of timber everywhere in this building. So literally the same parts that are repeating. And then there is an exception. You always need to know when to stop. Like, don't do everything with these parts. At some point, you need to throw in, I think, an exception and be like, for example, anything for me personally that caters to the human body, I don't want to do that with blocks or with my parts. Then you need to throw in something else. So I asked a friend of mine to design this staircase and put it in there. And again, I think this is radical and organic as a kind of as a space. And probably the most extreme radicality of this proposal is maybe not its kind of form, but the way how it would be produced. Because actually, only the first 10 centimeters of this building are the existing construction industry. That's the glass. It's the Apple shop glass, super expensive. And it's an existing kind of product that is a commodity. But the other 99.9% of this building is digitally fabricated just out of timber that comes straight from the forest. And that is, I think, amazing. And that is the most radical thing about this building. It's something very, very different. So then I pushed this. We ultimately lost this competition, and then I won this competition, which is for a small building, a museum building in Belgium, where we used exactly the same idea, because if you think that you have a good building, why start again from scratch? Just try to do it again somewhere else. So just, we just rotated these parts in a slightly different shape. And it's again a boring idea. It's just the cliche of architecture. It's a gabled roof, nothing special. But in the way that it's built, it has nothing in common, again, with how you would build architecture today. It's a repetition of these modules that are all prefabricated, and you attach them together, and then purely through that kind of aggregation, you get, again, a kind of a quite exciting space for this. And then on the outside, it's just wrapped in EPDM rubber, like there's no finish. We just close the building with the rubber. Yeah, but then the question is also like, how simple can it be, right? Why do these elements, I have an obsession with these triangular elements because I think they're beautiful. But at the same time, I wanted to also try out what it means if you do this really, really, really blunt and make it as simple as possible. So I built this installation in Seoul in South Korea, where I decided to build architectural models because I like architectural models. The only thing is these are ultra-large architectural models. They are scale 1 to 2. So this building is half the size of the actual building. And there are 2 houses. And you see this is my local Korean team who is building these architectural models and are sitting and climbing over these models. And they are just fit together again with cables. So you see the cables sticking out. So these are just hollow timber boxes with a cable, and then you span the cable and your building is put together. If you're bored with your building, you undo the cable and you can take your blocks and you can start again. And it's very fascinating for me to this would be exactly how I would build a building. So the architectural model is actually also the same thing as the building. And there's one really boring one, like really kind of like a domino, and then one that is maybe a bit more exciting. I quite like the kind of the dialogue between these 2 models. And then you see the scale of these architectural models. And it's quite an interesting, I didn't manage to go there myself. It's very sad because of COVID, so I've never seen them in person. But I imagine that it's quite interesting to kind of study these models, right? And then put your head into these spaces, and then kind of see how, these 2 models, the more boring one and the more maybe exciting one, which kind of spaces they create with the same parts, and kind of architectural ideas that you can put in these parts. And again, the tension cable sticking out, and then you get this kind of really primordial and primitive and basic architectural spaces that are maybe a little bit, I don't know, you can see, and it may be a little bit a Mesian space or a fluid space, and then another one is maybe a kind of more brutalist space. So that's the experiments with the boutique office. But then, of course, this is deeply, deeply contradictory, what I just showed you. Because the systems, I made an argument in the beginning of the lecture that we should think about housing, and I've been showing you cultural projects for museums, right? So that's just really sad that I put all these efforts in all this research to then do some museums and lose the competitions, right? And the real purpose of these systems is to be replicated with thousands, right? It's really the idea of this, what I call beauty in large quantities or generosity in large quantities. Can we design something that doesn't have to be too special because we'll repeat it, but something that kind of works in large quantities? And I've always been really fascinated by this. Like actually, I remember as a kid, one of the reasons why I wanted to become an architect was because I couldn't understand why modern streets with modern architecture are always bad. Like an architect never manages, you can design one good house, but I don't know a lot of architects who can do 20 houses in a row that are good, right? And for me, that's a question of architecture. It's not that one good house, it's like to do this 10,000 houses, right? In large quantities and make it work with the same qualities as maybe the historic references. And to do that, you need to invent, of course, an entirely new model. So we decided to kind of make the leap we made during COVID. I stopped traveling and I was at home and all my colleagues were at home. So we decided to make a spin-out company from our university lab with the help of the university and some government funding in the UK, and really start a tech company. And so now we've been doing that for 2 years. And I want to share a little bit like the work behind this, right? So the idea of the company is to build a platform for affordable housing. The mission is really to build high quality, affordable timber housing in huge amounts. The approach we take to this is not that to build this kind of large Soviet Union style massive factories that cost an enormous amount of money, but to build tiny little factories where we just have one robot that can build our building blocks, can take these building blocks and assemble them together. So this is our little factory. This robot, in 1 minute, it can build one box while we are in the pub having beers. So it's incredible that it can do this. Then we've developed, of course, kind of a whole set of little software tools that help us kind of understand the building processes, and also like specifically always asking, like where these values are, right? Why are we doing this? We're not doing this necessarily like to make an enormous amount of money or something. This is really with the idea to be able to create a large platform for affordable housing, right? And to crack that question of an automated architecture. And that's kind of the principle, right? That we believe by radically reducing the kind of initial complexity of architecture by building this building block that precedes a building, you could construct all these kind of features. And we started kind of setting up this micro factory that's in Milton Keynes, like close to London. We're doing that together with ABB, which is a large robotic company. And then we also started to kind of slowly introduce an experiment that's very early on during COVID. We built this with a local community in Bristol, in a very poor area in Bristol. We got together with a bunch of people who all lost their jobs during COVID and kind of tried to work with them around these ideas of housing platforms and automated housing, try to teach them some new skills. And then we built together this kind of housing prototype with the idea that the desperately needed housing in that area could maybe be accommodated by this. And actually this woman, Hannah, who was one of the people there, she now works for us in automated architecture as our local kind of microfactory person in Bristol. These are some of these qualities which we started to explore in these buildings. Again, of course, in a pavilion, but kind of questioning that affordable housing can be kind of as exuberant and as kind of maybe without any compromise, right? So there's almost kind of like, again, maybe a Frank Lloyd Wrightian kind of strange space, and like this is dirt cheap and affordable, right? That it's not that if you do affordable housing, you cannot be interested in aesthetics and it needs to be sad. Like this could be very kind of, a very different world. Then we did a kind of a crazy thing where we built with Hackney Council, which is a local council in London. We built an enormous amount of these blocks and then assembled it into a 2-story house. Also to kind of prove, and like for ourselves as well, the interesting question, could we really do this with exactly the same block? Just one block, built this entire thing. And it works perfectly. You could, it has really big cantilevers again. It does really strange things. And that really, we really presented this again to this, as also like a very kind of difficult community in London. We again presented that as a model for affordable housing. Like really saying like, we need to radically rethink how we build. And if we do that, maybe there are so many more possibilities that open up, right? So we did like a series of talks in this pavilion. The mayor of Hackney was there, and they got very excited in this building system. Okay, yeah. Some of these qualities, and then again, maybe a little bit of a domino, right? And now what we're doing now, because obviously it's easy to build this, right? Because it doesn't have a cladding or technical devices or anything. So now we're essentially building very humble and tiny homes that we really try, because we can build those at a very high speed. We can do it in like 1 a week if we want to. So we use this to very quickly iterate and try out, learn from the failures, and test our software, test our robotics, test everything very quickly on these small products. and see if we can completely kind of produce that in an entirely digital way. And they're always made with the same parts, but slightly different. And again, this thing costs, well, in Portugal, it would be maybe a lot of, like in the UK, it's very cheap, let's say. Like we're delivering this at a very low cost for UK standards. And we have a kind of quite busy, we have a lot of these cabins that we're building now. And then at the same time, we're pitching for housing projects and starting to kind of try to scale that up, right? While we're going for funding to do this. So we want to go in the next 5 years from 5 to 10,000, the old dream of Walter Gropius, with maybe then ending up, from the garden studio, the 5 garden studios, to maybe the 10,000 of, who knows, apartments or housing blocks. And then maybe it could look a bit like maybe this image. So if you're interested in this work, you can follow AUAR and myself and learn more about that. Thank you.
So we'll have some time for some questions from the audience. I'm sure people are very curious about this. So, any questions?
Who will start?
No? I can make maybe a provocation. So, you showed us a lot of failed systems. What will keep your system from failing? Have you thought about this?
No, that's but I also deliberately show it, right? So every time an architect tries to do this, it fails. We know that. But like, you need to keep dreaming. We need to be optimistic, right? So maybe this time it won't fail. Like
believing it.
We need to believe it. Like if you can't believe in that, I think you have a problem, right? I think we should believe in that as architects, that we can do this, even though it failed so many times before.
So we have one question here in the first row.
Gilles, for the extremely great work and lecture. I think also to dare proposing something like this is the fantastic part, so the question. I mean, but I have one particular question. Throughout the whole lecture, you explained that all these things need to be automated. But what you didn't really touch at is how are they designed. There was one slide, but then you moved very quickly to another argument saying, yeah, there is a voxel system and computational design. Then, is this because you think this is not the question anymore once you have such a powerful system? But still, as I understood it, the provocation part, you say, okay, you have one good building, then just replicate it 1 million times. What is a good, legitimate question? But this is not what you have in mind with your system. System is much more sophisticated, and probably this is why you hope that you will not fail with this. But there is something in between artificial intelligence or some stupid, generator or configurator. But that still needs the unique and probably not at the boutique scale, but some thinking about how I'm going to solve this problem with this generic part for this specific thing.
Yeah.
What about this?
No, I think, Fabio, that's probably the most difficult question. And it's nice you picked it out, right? Because we've set up a system that essentially can accommodate an enormous variety of design while being repetitive. So it's true. My argument is not to design, one single typology and then multiply that. Because also we know there's many reasons why that would not work. And that's also the reasons why a lot of these modular housing companies are always in really big difficulties, because they're forced always to adapt to very specific local issues. So we've set up a system that's actually very similar to Walter Gropius' system, that the idea is that every building repeats, but it never exactly repeats in exactly the same way. But what we're struggling with now is that we've created for ourselves such an incredible freedom in how you put these parts together that we need to make a decision on some typologies that we want to push for, on some directions. And until now, they've mainly been guided by my own aesthetic intuition, to be honest. Like that has really been kind of me playing around and then figuring out some things that aesthetically and spatially, I think, work. And then we try to automate that with some simple scripts, and we make some patterns, very simple stuff. But the real question now, what we're going to do in the next, like when we scale up from these garden studios, because these garden studios are very easy to do, they're very formal, right? There's no big architectural questions. The big question now will be like, okay, you can technically design with these blocks, you can design a chipper field if you want to. You can design, maybe you can design a Caesar, I don't know. If you paint them white, maybe you can design a Caesar with it. But like there are so many possible ideologies that you can, or positions on architecture that you can take within that model. So in a way, this is coming back a little bit as a boomerang to us, that we will have to make a position there and have a position on like, do we push for kind of maybe something in that direction, and we say like, you cannot do this, or we don't offer that. So no answer yet to that, but I think that's also what I'm personally super excited by. Like we will really be designing in the next few months this kind of ideas for architectural ideas for houses, housing blocks, and trying to then figure out what works, what doesn't work. Yeah.
Great. So, any more questions?
There?
Yeah. No, it's not. Yeah.
Yeah.
Oh.
Thank you for the amazing lecture, Gilles. I guess my question is also a provocation, and maybe a bit stupid too, but
Those are the best.
yes. So what we saw looks like an amazing, decentralized, maybe is a word, structural system. But there was another lecture, I think, yesterday that made a very good point that what has been ballooning as a cost in the construction industry is actually the construction of the facilities and the finishes, the envelope. So as I was seeing this, because we've been in similar positions in our practice, I was thinking, oh, this looks amazing. How do you coat it? How do you shield it? How do you roof it?
Yeah.
What are you going to do with the ACs? So, of course, it's a stupid question, but have you started thinking about it? Like, I would love to see a decentralized construction go together with a decentralized climate control system and a decentralized envelope. Of course, I'm not asking that you solve this in front of us now. Yeah. These are like huge constellations of problems, but is this part of your thinking?
No, absolutely, and I think it's not a stupid, it's a super relevant question, right? Because it's true, and I mentioned it briefly in the lecture, the easy part is doing the core, right, the shell. I mean, that doesn't actually even cost that much anyway in architecture. Like, the difficult part is everything else. So we're quite proud that with these tiny little cabins who look very innocent, that they don't look like a big thing, but we're quite proud that that is, of course, like fully insulated, waterproofed. The windows, for example, we designed our own windows that are also digitally manufactured. The cladding is as well digitally manufactured, and we can position that with a robot, etc. But I do have a big problem with this cladding system, because I'm really someone who loves monolithic architecture. Like, I like extreme simplicity. So I got massively frustrated with these cabins, with the fact that suddenly there were layers again, and there was tape. There was someone taping waterproofing. I was like, this can't be, I mean, this is like, we're already defeated, right? Yeah. Like, this is not automated architecture. This is like someone taping the breather membrane together, right? And so now I'm super interested in that question, like, what are the alternatives? Like, for example, now we're actually looking also at things like hemp. You can spray hemp. So I have this dream of building these timber cassettes and then just, you know, spraying them with hemp to avoid that, these layers, for example, right? And then the super interesting question is, of course, climate and the actual HVAC systems. And actually, I mean, with the concert hall, the boutique project, we actually there embedded in every element together with, there's a German company called Transolar, which is a very famous climate engineering office. So they developed actually that idea of a kind of a more distributed version of HVAC running through that building. So there are some super interesting ideas around that, and I think you absolutely need to take them into account. Because we just quoted 15 houses, and I was surprised how expensive they were. And I know why they are expensive. They are expensive because of the HVAC. So if you want to make them as affordable as I hope they would be, plus the margin that we would take on it, which is also a large margin, not 1%, but 20 or 30%, then we are still very far from that. That's absolutely true.
So, any more questions in the audience? Yeah,
There.
on the back.
In the back.
Okay, thank you, Gilles, for your brilliant presentation. I have two questions that I would like to make, because we live today in this moment where we have to be very careful in using our natural resources, and you are using a lot of wood here. And let's say you are also working in a kind of prefabrication paradigm of standard components. So you are in between the boutique approach and the modular construction approach. You are here in between. And I was wondering about, let's say, some values that I see in your approach that could be interesting for the current moment regarding sustainability. And one question is, how are you looking at material optimization through your system? Because if you are using always the same component, of course, you are ending up with, let's say, using more material than needed. And we are in this age of digital customization, and you have these microfactories that could easily, let's say, eventually moving away from the rigidity of this approach to customize and adjust the use of materials. This is one question. No? The other question is one very interesting thing that when I see your projects, it reminds me, it's about disassembly. And you never talk about disassembly, but when I see you assembling all these pieces to make one project, I imagine disassembling these pieces and make a different project with the same pieces. So how do you see this, or have you been exploring also this possibility, which is, let's say, most difficult to do when you embrace modular construction, because then it's always the same model and everything is defined there. No? So these are the two questions, no? Material optimization and design and disassembly.
Thank you.
Thank you.
Great questions, and I think they are somehow related maybe as well. So I'll maybe try to use the second question to answer the first one, and they could be related. So I think architecture for disassembly is crucial. I think it's super interesting that as an architect, you don't only design a building to be assembled, but also to be disassembled. And of course, that goes together with questions around circular economy and reuse of these materials. And it's actually a pity. So the project in Seoul I showed, the two really large architectural models, I've actually just taken those apart and reassembled it, and now it's a permanent museum shop because we didn't want to throw away the pieces. So that worked really well. Like, we literally just loosened the cables and made something else with it. A massive bookshelf, actually, like an enormous bookshelf. And that's actually also, I think, part of the question of that idea of like parts that precede buildings, right? So in my world, the parts exist before the building exists. Like, I cannot customize a part because there's no building. Like, my parts are already made. I have a pile, 200, 400 of these building blocks that are ready and that then will be assembled in a certain building. So there's no way that even conceptually I could customize them to accommodate for something specific in the building. Also with ultimately the idea, and that we have never not tested yet, but ultimately also with the idea that all these buildings that we built are completely circular, but like radically circular. That is blocks that you could completely untie them again and again reassemble them later in another building. Like, they almost become a kind of a currency. Like, you could follow the kind of the life of these blocks, right? Like, maybe this block in your building has spent 5 years with lady this and this in that house, and then it was part of a library maybe in this community, and then it was a bar, and now it is part of your ceiling. And maybe we could track and ledger kind of the life of these blocks in a kind of a truly kind of circular model, right? So that's, I think, maybe a way to think about that. That maybe the way to save materials is not necessarily in kind of maybe one instance in the lifetime where you optimize it, but maybe across the kind of lifetime. And we're doing now, I mean, it's a super interesting thing. Like, we've actually developed now a data model with Arab together to do a carbon assessment of the current modules. And not only of the modules, we also track the amount of glue that we dispense, the transport, the screws, the steelwork, etc. And with them, we're kind of hoping to figure out also a little bit better. I mean, it's net zero what we are doing, but we want to figure out, these other questions around like life cycle and what that means, right? And an interesting thing, I mean, maybe a provocation related to that around timber, right? Like, I think ultimately my dream would also be with this platform that it would actually become materially agnostic, so that it doesn't know the block maybe is not timber, maybe it's also, it could maybe be something else. And like that's kind of the dream, right? Like maybe the true value is not that block, but it's the method to approach architecture, and maybe then you could do it in other materials, because I think if you build, for example, in Greece in timber, I think that's a crime. No, you can't do that. Or certain parts of the world have no access to timber, so you would maybe do it in rammed earth, as we saw earlier in Sergei's work, right? Or other materials. I think that could be interesting.
Great. So, one last question.
No?
No? No one?
I have one. So,
Yeah.
do you think with this digital evolution, the traditional office will disappear, or will need to change the approach to architecture?
I actually don't think so. So I think what I'm showing is not a threat to the amazing, beautiful boutique offices, because they do, the kind of the 1% of, you could call them culturally relevant projects, or, projects for people who are maybe really interested in architecture, and they serve that market, and that's that one. I'm interested in the 99% irrelevant, ugly, stupid projects of today.
Yeah.
And then I can still have my own little boutique office that does like special projects, right?
Yeah.
But yeah, it's absolutely, I think, no threat. It's actually a claim for more architecture in the places where now there is no architecture.
Okay, thank you.
So, we end here. Gilles' participation. Thank you very much, Gilles, for coming to
Thank you,
Porto
Thiago.
Thank
here
you.
with us. Well, and we move on to the next presentation. Thank you.